Hey guys, this is Megan again from OnlineMathCircle AIME video tutorials, and today we are going to look at 2009 AIME I, problem number 13. The terms of the sequence a sub I, defined by a sub n plus 2, equal to a sub n plus 2009 all over the quantity 1 plus a sub n plus 1 for n greater than or equal to 1 are positive integers. Find the minimum possible value of a sub 1 plus a sub 2. So, in order to start to approach this problem, we can use a method known as indirect proof. Indirect proof. And basically, the way that this type of proof works out is that we start out by making an assumption, assuming that a certain statement is true. Then we carry out the proof of that assumption. And with the nature of an indirect proof, that assumption will eventually lead out to a contradiction, which means that we have to prove that the assumption is false, which will conclude the basic structure of an indirect proof. So, how are we going to do that for this problem? Well, first of all, we notice some relation between a sub n and a sub n plus 1. And just by looking at the nature of this recursive formula, it may seem to us that there's a relationship between the product of a sub n and a sub n plus 1 and the number 2009. Well, we can try to see if the product of a sub n and a sub n plus 1 is equal to 2009 or not. So let's start off by making an assumption here. Let's first assume that a sub n is not equal to 2009 over a sub n plus 1. So, if we assume this statement, we must conclude that a sub n, which is equal to a sub n over 1, is less than a sub n plus 2009 all over 1 plus a sub n plus 1, which is less than 2009 all over a sub n plus 1. This case here is if a sub n is less than 2009 over a sub n plus 1, or a sub n times a sub n plus 1 is less than 2009. A second possibility that we can look at is if a sub n is greater than 2009 over a sub n plus 1, or a sub n times a sub n plus 1 is greater than 2009. So, looking at this inequality, we basically just have the reverse of this first chain of inequalities. So, that gives us 2009 over a sub n plus 1, which is less than a sub n plus 2009 all over 1 plus a sub n plus 1, which is less than a sub n. Now, looking at both of these possible inequalities that come from the assumption that a sub n is not equal to 2009 over a sub n plus 1, we see that there is an infinite sequence of integers between a sub n and 2009 over a sub n plus 1. So that means the integers are constantly increasing or constantly decreasing. But eventually it's got to reach its limits. So suppose that a sub n is less than 2009 over a sub n plus 1. If that is the case, then that would mean that the integers in the sequence would be increasing. And if they keep on increasing, eventually there will be some point where if n is equal to I, that a sub I times a sub n I plus 1 would be greater than 2009, which would lead to a contradiction of this case. If a sub n is greater than 2009 over a sub n plus 1, then the integers in the sequence would be decreasing. And when they're decreasing, at some point, a sub I would eventually be a non-integer. Because if you have an infinite sequence of integers that keep on decreasing, eventually you'll get to some point where one of the terms would start becoming a fraction. So that contradicts the fact that the entire sequence a sub n must be integers. So the second case also leads to a contradiction. Since both subcases lead to contradictions, this original assumption that we made here is indeed false. So what does that mean? Well, that basically means that we have to have a sub n equal to 2009 over a sub n plus 1, or a sub n times a sub n plus 1 equal to 2009. So this means that a sub 1 times a sub 2 is equal to 2009. Now the original problem statement asks us to minimize a sub 1 plus a sub 2. So looking at this product here, we see that 2009, written as the product of two numbers, would be equal to 41 times 49. And this is the factorization that would lead to the smallest possible sum, because a1 and a2 would be the closest together. So in this case, we would have a1 equal to 41 and a2 equal to 49. And the minimum possible value of a1 plus a2 is just 41 plus 49, giving us a final answer of 90.